So we had our perimeter, and perimeter is really all the side lengths, ENG, lengths added together. That's all perimeter is. We're just adding all the side lengths together, okay? Now, one of the interesting things with perimeter is that for most of the shapes we're going to deal with, they're going to be pretty basic shapes. A square, a parallelogram. I mean, there's no indentions. Does this make sense? There's no indentions to them. So it's not. Now let's look at this here. This here is a parallelogram. It's a four-sided figure. Let's try to extend the page. Of this here. So what we need to find is the distance. Now, two of the lengths are kind of given to us. Not directly, but kind of, because they're what? On a straight line, yes? So we have 1, 2, 3, 4, 5. So this here is a distance of, but down here we've got 1, 2, 3, 4, 5. So this was kind of easy because it gave us two of the lengths, yes? So we just need to find the what? The other two. And we're going to do that by using the distance formula. So we're using K and N first. And really what we're doing is we're going to use the square root, put the x values together, put the y values together, and subtract them. So our x value is what? -1 minus -3. Our y values is going to be 1 minus -2. Yes? Now, for any of you that struggle with the distance formula and whatnot, simplifying what do we do, kind of how it works, all the ins and outs of it, are we all comfortable with this here, setting this up and plugging it in, yes? If you struggle with simplifying it at all, type it straight in the calculator. Don't simplify anything. Square root, open parentheses, -1 minus -3, close parentheses, squared, plus, open parentheses, 1 minus -2, close parentheses, squared, hit enter. It'll do it for you. To quote Albert Einstein, if there's anything that I can look up within 5 minutes, there's no reason to memorize it. Literally. Albert Einstein, one of the greatest minds, one of them of our time. Yes? You all know who he is? Did not know his street address. They asked him what his street address. He asked for a phone book, got it, looked himself up, and said, that's it. If I can look it up within 5 minutes, there's no reason to memorize it. So this here, same thing. If we know it, awesome. But if you struggle with this, plug it in. Plug it in. Because I'm going to simplify it here, because 1 minus -3 is going to be 2. 1 minus -2 is 3. 2 squared is 4. 3 squared is 9. And we get the square root of 13. Any questions on this so far? Calculator just goes. And guys, if you want to use a calculator in here, use it. Plug them in. Plug them in along with me. Because there's nothing saying that I can do that I'm not going to make a mistake on some of this here. I do get the square root of 13. Any questions on this here so far? So what do we have to do next? The other side, L to M. Possibly. Because if we know our properties of triangles, we could say that. If we know that this is definitely a parallelogram, we could possibly say that. But do we know either of those things? No. So we're going to go on and show it. So here L is 4, 1, so we have 4 minus our x value is 2 squared plus, then we have 1 minus negative 2 squared. And again, at this point here, you can plug this all into the calculator. Or I'm going to do it by hand. 4 minus 2 is 2 squared. 1 minus negative 2 is 3 squared. Hey, same thing, yes? So it does work out that it is the same. 4 plus 9 is equal to the square root of 13. So what are our two side lengths here? We have the square root of 13 and the square root of 13. And 5 and 5. Those are our 4 lengths, yes? What's 5 plus 5? What's the square root of 13 plus the square root of 13? And it's not the square root of 26. Almost. How many of them do we have? Two square root of 13s, because how many of them do we have? 2. 10 plus 2 square root of 13. And that's it. Because with those radicals, we can almost treat them similar to variables. They're not the same, but they act like it. Because if they're the exact same, so if I have the exact same radical, so the exact same square root, 13 and 13, like here, we can combine them. There's 2 of them. But like the square roots we dealt with yesterday where we had 2 different ones, we can't combine them because they're not the same thing. Any questions on this here? We good with perimeter? Yes? Then we'll move on to area. Finding the area. Now, like I see, I did uncover this one for you. You already have this here, yes? Now, the area formula for a triangle is what? Mm-hmm. 1/2 base times the height. Triangle. Why is the area formula 1/2 base times the height? Y'all know? Exactly. So this is a square, yes? And I could go and measure it and show you that this is exactly a square. But what I can do here is if I fold this in half across like this here.
Yeah, let's see. All right, so try to get it perfect.
I'm just trying to get it perfect. So we do have a triangle here, yes? Well, how many of them make up a square? 2. So the area of a square is the same. Well, 2 triangles make up 1. So the area of a triangle is half the area of a, what's the area formula for a square? Length times width, or we'll call it base times height. Because when we look back at this here, I really don't have a length and a width. I have the overall height of the triangle and the base. Okay? Now, height, one thing we look for with height that's normally, when they give us a triangle, they label H and B and kind of tell you what the height is. The height of a triangle, or we'll come to it again when we talk about triangles, it's also called the altitude. The altitude is a line that makes a right angle with another side. Okay? The vertex are the points where the lines meet, yes? if you can draw a line from the vertex to another side and it makes a right angle, that's the height. That's going to be the height. So with a right triangle, those two sides that make that right angle are the base and height, B and H. Here, we don't have it. We don't have a base and height. But what I can do is I can take this point here and drop a line straight down to the other side. Y'all see that there? And that right there, that T, because it is a coordinate plane, will make a right angle, just because it is a coordinate plane. So this right here is our height. Now the side that the height connects to is the base. Is the base. And we'll get into more specifics on this later, because we're gonna have several chapters on triangles. Triangles show up everywhere. So our base and height. Are those two straight lines on log and axis? Well, yeah, right? So what I can do here is go, what? 1, 2, 3, 4, 5, 6. I can count that, yes? 1, 2, 3, 4, 5, 6, 7. So the height is 6 and the base is 8. So we have 1/2 of what? 1/2 of 8 times 6, yes? Can I have rewritten that as 1/2 of 6 times 8?
Yes.
Multiplication doesn't matter, does it? The order? So we can plug this in, or we can do it in our head. That's 1/2 times 8. What's half of 8? 4 times 6. What are our units? What are we dealing with? Did they tell us? Feet, inches, meters, centimeters? So a lot of times in math, if the units aren't given, we call it units squared. It's just a unit. We don't know what it is. But area is always dealt in square units. Questions on this here? We good with this here? Covered area before? Yes? We have another triangle, and we want to find the area. So again, in any of these problems that we'll have, especially on the homework, you're either going to have a right triangle, a right angle, or we're going to be able to drop a line straight down. So on this one here, we have this line here as the height. Well, since it's along a straight line, we can count it, yes? So it's what? 1 in our base. So our base is 5 and the height is 'So this time I'm going to do 5 times 3 first. What is 5 times 3? 1/2 times 15. I don't think that they're going to ask you to put the units, but it is units squared if they're not given. Any questions on any of this here? Are we good with this so far? Yes? Ready for the next one. Find the area of the polygon with the given vertices. It's already graphed it for you, so we have this here. So what's the area formula for this shape? So we'll use length times width for this one here. Length times width. Well, luckily for us, it's on straight lines, isn't it?
Yeah.
So we can just count across. So we'd have what? 2, 3. What would it be? 3 times 3 would be 9. Could be 9. More specifically, this wouldn't be a rectangle, it would be a square. It'd be a parallelogram, it'd be a quadrilateral. There's many different names for them. And when we get into the chapter on polygons, we're going to go through naming them. You'll have to name them. Questions on this here? Are we good to move to the next slide? Yes? I'm going to ask a bold question. Do y'all need to see another example of area?
No.
We good with area? Even if this thing's not on straight lines? I don't think we have. Essentially like how we were dealing with perimeter with it tilted, where we had to use the distance formula. It'd be the same thing. We just have to find the distance. So we good with area and perimeter? Yes? Doing another is not going to help anybody? Nope. We good? Y'all can go on. I'm gonna be done for the day. There's one. So